Hi. Well, we're going to talk about the distributive property and also loss of exponents. Okay, so let's get started. First thing, what is a distributive property? It says that multiplying a sum of a number is the same as multiplying each addend by the number and then adding the products. Now, as you guys can see here, these will equal these right here. Why? Because we're multiplying each one individually and then adding them up, which would be the same thing as adding a and b first and getting a result and then multiplying times x. Okay, so let's see how that works. For these we have that x equals 2, okay, and a equals 3 and b also equals 2. So we have 2 times 3 plus 2, and that equals 2 times 5, which will equal 10. So far so good. Or we can go another way, which would be 2 times 3, we get a result, and then that plus 2 times 2. And then we would have 6 plus 4 equals 10. See? Either way, it gives us the same result. Now, let's go on to the power loss and the loss of exponents. First, we have product of powers. We have that if we have a to the n times a to the m, this will equal a to the n plus m. Now, how can you do this? Easy. Whenever you guys have, like, let's say, I'm gonna do it right here. This follows true because whenever you guys have, like, let's say, x to the 1, okay, which would be just x times x to the 2. Okay, that should give you guys x to the 3. Why? Because that equals 2 plus 1. Okay, and let's switch it with numbers. We got 2 to the 3, and if x equals 2, 2 to the 3, how much is that, guys? It's 2 times 2, 4, and 8, and that should give you the same result as having 4 times, I mean 2 times 4, yes. Okay, so 2 times 4, 2 times 4 equals 8. See, it gives you the same result. Why? Because this is a 1, it's here, and then the other one's right here. Okay, good. So that's how we solve those. And we also have the quotient of powers. Okay, so this would look like this: a to the n divided by a to the m equals a to the n minus m. Now, this just basically what it means is that um, that all negative exponents are actually just division. Exponents actually just a denominator. Okay, as follows. See, x to the minus 2 equals 1 divided by x to the 2. Okay, there you go. So if we were to have and x to the 3 minus 1. That should give you guys how much? X squared. And also another way of putting x squared would be to put it like x to the 3 divided by x to the 1. Okay. Why? Because 3 minus 1 equals 2. And you see how it also follows here. It also follows here. The 3 and the 1. If we're dividing these, it should give you x squared. Well, let's see another one. The power of powers. Now, whenever we have something that has a power, and then we're actually powering that, then we have it like this. Okay, so let's look at an example. See, it's gonna be the one right here. What is the value? Y4 third. I mean y4 to the to the to the cube. Okay, or to the third. So for that we have y to the 4 to the third equals 4 times 3 equals 12. Okay, so it should equal y to the 12. There you go. Now let's see in all other laws. Negative powers minus equals division. See, I already told you that, guys. Fraction of powers n divided by m equals m and n. Okay, why does this happen? Because let's say here, let's just say this is also n divided by m is b, like for example, and then b would just be what n divided by n m is, right, guys? So another way of putting this example would be, let's do it, a n by m equals b. So b can be any number, and let's say b equals 4, right? So, and then let's say n would have to by default equal, I don't know, like 8, and m would equal 2, right, guys? Because 8 divided by 2 equals 4. Well, 8 to the 4 should equal square root, okay, of 8 to the 8th, and there you go. And square root of 8 to the 8th should give you guys 8 to the 4. There you go. So you guys can see how it follows, right? It follows because n divided by m is actually the whole result of the exponent. Is the whole exponent, and it equals b. And then b, if b is 4 and n is 8 and m is 2, it follows true because 8 divided by 2 equals 4. There you go. There you go. Okay. So yeah. So let's get on with the problems. It says, what is the simplified form of x to the 2, x to the 3, x to the minus 1? Okay, so we have there x, and we can just add and subtract this all. So we have 2 plus 3 minus 1. How much does that give us? That should give you guys x to the 4. Okay, there you go. Now simplify this thing. What is the result? Now for that, we can actually we have two parts here. So we have 2a minus 1 and then we have a to the 7. Okay, I'm just zooming a little bit farther, not that much. There you go, a to the 7 and a to the 2. So a to the 7 and a to the 2. Um, let's just put it as a 7 minus 2. Okay, and this is gonna be equal to 2a minus 1 a to the 5th. Okay, and we go farther here, and we're now multiplying. Okay, we're multiplying, so that should give you guys 2a to the 1 plus 5 6 minus a to the 5, and this is our result. Okay, there we go. We already done that one. We're gonna do this other one. What is the value of y 4/3 times, I mean, to the 6? So y 4/3 to the 6 should give you guys y, and then we have 4/3 times 6. Okay, is equals to, now here what I would do is, instead of multiplying, I would I will further simplify 6, but this is just me. All right, you can do it the long way also. What do I mean by this is that you guys can be like y to the 24. Wait, yeah, y to the 24, 24. Okay, divided by how much? Divided by 3. Okay, you guys can go like that. You guys can go like, okay, so it kind of like got a little bit stuck, my stylus. But see, what I wanted to point out is that we have this right here, okay, which is y to the 4/3 times 6 would equal 24 divided by 3 on the exponent, and it would also equal, if we went another way, which was 4/3, okay, which was 4/3 times 3 times 2. Why? Because 3 times 2 equals 6, so we have to slash it, this thing right here, and also slash this thing right here. Okay, there you go, and that should give you guys, should give you y to the 8, and there you go, you have your result now, y to the 8